Happy Thursday. Just closing up on this chapter. This is actually really finishing the new curriculum. So starting next week, there'll be kind of like review assignments to work at. So that should be a welcomed break. Just sort of kind of like a review for a quote unquote final exam. But anyway, for this review sheet, number 2 came up twice, and then 4 and 16. So number 2 says that the function f is defined for all real values of f, and then they tell you that the derivative of the function is x cubed minus x squared over 1 minus x. So we're dealing with a function that's defined everywhere, and here's the rule for its derivative. For what values of x is the function of f increasing? So we want to know, essentially, if we want to know where it's increasing, we want to know where the slope or its derivative is positive. So where is this positive? So your critical points come from zeros and undefined. So you're certainly going to have an undefined at 1. You're also going to have, so you're going to have zeros at any place where the cubed of the number minus x. So actually, let's rewrite this. I'm going to get rid of this because now I'm taking it back and I need space. I think I would, if I were to do this, because this is really what our numerator means. I would factor an x out of that one and an x out of that one. That would leave the first one with x squared minus 1 and the second one with x squared minus 1. So the numerator would be x squared and then x squared minus 1 squared. So the numerator is going to be zeroed out at 1 and negative 1 as well as at 0. So these are my critical points. I want to see whether the derivative is positive, negative in each of these intervals. So if I were to plug in a negative 2, now your numerator is always going to be positive. 1 minus negative 2 is 1 plus 2 is 3. So positive or positive, it's definitely increasing there. At negative a half, it's a positive over 1 minus negative a half is 1 plus a half, so over another positive, so it's still increasing there. At positive a half, it's going to be a positive over 1 minus a half is still positive, so it's a positive there. And at 2 and beyond, it's going to be positive over, well, really beyond 1. 1 minus 2 is going to give you a negative number, so that would be a negative. So, where is this? Oh, my screenshot of it went away. For what values of x is this function increasing? On a lot of them, but it says everywhere between negative 1 and 1. Not totally true because it's undefined there. Anywhere from 0 to 1, that is true. Okay, so maybe what confused people about this one is that it's not giving the full answer. It's just giving like, yes, this is an interval where it is increasing the entire time. There are other times where it's increasing as well, but on this interval, it is increasing the entire time. But there it's not because 0 is exempt. There it's not because anything less than 1, 0, and negative 1 are exempt. Being greater than 1 is certainly out. And being less than 0 is good, except for this should be exempt. So the only one that is fully and completely true, albeit it's not, you know, the full, it didn't say what are all of the values, it just said which one has values that are increasing the whole time. So for that reason, it would be B, which I should probably check to make sure it wasn't a mistake, because that does sometimes happen on here, where the answer key is wrong. Goodness, this is a long review sheet. Good thing we split this one up. Number 2 is C, it says. So maybe it was a mistake. Maybe that's why I had the questions. And C says anywhere where x is less than 1. Which is not true, because we have a slope of 0 at -1, and that would not be all of them. So just to see for sure, oh shoot, we can't exactly plug this in because we don't know the original function formula. I'm going to contend that this is, I mean, at the end of the day, this is like a nitty-gritty formality here. I mean, obviously we know that pretty much everything less than 1 works, except for 0 does not, because 0 leaves you with a 0 slope, which is not increasing, and -1 leaves you with a 0 slope, which is not increasing. So I would say that this was wrong because it was just careless in its wording, maybe, is what I have a problem with. But I think probably now, after doing it, that's what the question was with too. So the answer is B. So if you got B, you would be correct. I see why they're saying C, but they're ignoring the moments where the slope is not increasing. It's in fact 0. If we had the original function, we could type it in C, but we don't. So I'm still sticking with B. I'm still sticking with it's a typo. I'll let you know if I find out otherwise, if I hem and haw and think about this further and come up with something, but I'm pretty sure that that's just a typo. Number 4 says an equation of the line tangent to the graph of f of x equals 2x cubed minus 3x squared at its point of inflection. Excellent question. So we are going to try to write the equation of a line that's tangent to this graph at its point of inflection. So the first thing we have to do is find that point of inflection, which is going to take us right to the second derivative, which is not terrible because this is just the power rule. 6x squared minus 6x, and then the second derivative is 12x minus 6. So its point of inflection, when that equals 0, is going to be 1/2. 1/2 comma what? Well, to complete the point, you have to plug 1/2 into the original equation. So 2 times 1/2 cubed minus 3 times 1/2 squared. That's going to give us 2 times 1/8 minus 3 times 1/4. So we get 1/4 minus 3/4, which is -2/4 or -1/2. So there's our point, and our slope, if we're writing the equation of the tangent line, we need a slope to go with that, and we're looking then for the slope, which is here at an x coordinate of 1/2. So the slope is 6 times 1/2, I'm just stealing that and plugging in 1/2, 6 times 1/2 squared minus 6 times 1/2, which gives us 6 times 1/4 minus 3. 6/4 is 3/2 minus 3, that's 1/2 minus 3, that's -1/2, which is -3/2. So there's my m. So point slope, write the equation. Okay, here we go. Y minus -1/2 equals m x minus 1/2. Y plus 1/2 equals -3/2 x plus 3/4. Now I'm going to clear the fractions by multiplying by 4 on both sides. And I'm doing that partially because I've already taken a peek at the options, and they're all in number 4. They all are in standard form with whole number coefficients. So I can't have these fractions if I want to achieve that. So I'm going to multiply by 4 on both sides so as to clear the fractions. It's going to give me 4y plus 2 equals, the 4 and the 2 are going to reduce to 2 times -3 is -6x plus 3. And then when I add my 6x over, I'm going to get 6x plus 4y equals subtract my 2 over, and I'm going to get 1. So 6x plus 4y equals 1, which is option C. And again, I'm going to check that just to make sure I didn't make a mistake. Number 4, option C. So, I love that question because it navigates through, do you understand the first derivative? Do you understand the second derivative? Once you know the point of inflection's x-coordinate, can you go back and find the slope at that? Can you go back and find the actual point at that? Can you then write the equation of the tangent line? It's a beautiful question. It really brings it all in. Don't call me a geek in your head. I know that's what you're doing because I called it a beautiful question. Keep your comments to yourself. I'm laughing out loud because you obviously have to. Although some of you have picked on me via remind texting, and I do appreciate it. 16 says, for what values of x is the graph of that concave up? So concave up means we're looking at the second derivative. I'm going to rewrite this as 1/2 x squared plus 4x to the negative first so that I can just use a straight power rule. But we need to know where the second derivative is positive for concave up. So first derivative, bring my 2 out, that's a 1x to the first. And then bring this out, negative 4x to the negative second. Did I get that right? The 2 comes out in front. Makes it a 1. X to the now first power. The second derivative is 1, bring your negative 2 out, plus 8x to the negative third, which is 1 plus 8 over x cubed. And we want to know, where is this thing positive? So we want to find our zeros and our undefines. It's certainly undefined at 0. But when does this thing equal 0 is going to be when 8 over x cubed equals negative 1. Cross multiply, you're going to get 8, go back this way, 8 equals negative x cubed. Divide by negative 1, you're going to get x cubed equals negative 8, which is going to happen at an x coordinate of negative 2. Okay, so here's where we're testing in and around, and we're testing for concavity, so we're testing second derivative stuff, which is here. That's my second derivative. So when I plug in negative 3, I'm going to get 1 plus 8 over negative 27. That's 1 minus a small fraction. That's still going to be a positive. When I plug in negative 1, I'm going to get 1 plus 8 over negative 1, which is going to be 1 minus 8. So that's definitely a negative, concave down. And when I plug in 1, I'm going to get 1 plus 8, which is still positive. So concave up anytime we're less than negative 2 or greater than 0. And if I look at my options, this was 16. Less than negative 2 or greater than 0. X is less than negative 2 or greater than 0. So that would be option C as well. And let me just check to make sure it's right. 16 is C. So, makes sense that I had multiple questions on number 2 because I think there was a mistake in the answer key. Or a look beyond the fact that these were exceptions. Other than that, hopefully we're good. I know a lot of you still have to get this in, but hope that helps. Any other questions? Don't hesitate.